Okay, so we have looked and done practice problems on stoichiometry where we're told, okay, you have this amount of one reactant, you have excess amount of other reactant. How much product can you make? All right, well, this is a little different because remember when I said, well, if it says excess reactant, we have plenty. Don't worry about it. But here we may not have plenty. So we're going to look at limiting reactant. And I'm going to show you a couple of pictures here. Notice here we have the small molecule here for hydrogen, the larger molecule for nitrogen. And this is the Haber process making ammonia. So what we're going to take a look at is the fact that for every one nitrogen, I'm going to need 3 hydrogen molecules, and that's going to make 2 ammonia molecules when we have a balanced equation. So, of course, we need to have a balanced equation first. But you'll see in this picture, we have a situation where we have 3 hydrogens and a nitrogen making 2 ammonia molecules. And it happens over and over and over again, right? And it's perfect. We have just the perfect amount of nitrogen, just the perfect amount of hydrogen, and we make the ammonia. 2 molecules of ammonia every cycle. All right. Well, let me show you a different picture here. And in this picture, same idea, but in this case, we have a situation where, yep, we're moving along here, and we're making the molecules, and then it comes to a stop. Now, try to visualize what's going on here because we have some nitrogen, right? It's left over, but we don't have any hydrogen to react with it. So the reaction stops, and it stops based on the fact that we have run out of hydrogen. So when you're calculating the product, realize that once the limiting reactant runs out, the reaction's done. Okay, so you can have some excess reactant. Okay, we can even calculate how much excess reactant's left over. In this case, it looks like 2 molecules of nitrogen are left over. In the reaction vessel, we have our product, but we have some leftover excess reactant. So this is what we'd be calling the excess reactant, and this is what we'd call limiting. And when you're doing the calculations, it's important to label what you have as your limiting, which one's your excess, just so, keeping stuff straight. Okay, so try to visualize what's going on here. We have run out of hydrogen. That is our limiting reactant, and the reaction is going to stop. Okay, so let's relate it also to a ham sandwich, which is maybe a little more fun than looking at chemicals. But let's say that we make the world's most boring sandwich. It's got 2 slices of bread, a piece of ham, and it makes a sandwich. Okay, so if you had exactly 2 slices of bread and a piece of ham, you could make 1 sandwich. Of course, that's our balanced equation, if you will. Now, what if you had 16 slices of bread, 22 pieces of ham? How many sandwiches could you make? Well, you're going to look at this and say, well, I'm making 8 because I need 2 slices of bread. And if I have 6 for a sandwich, if I have 16, that's 8. I'm going to make 8 sandwiches, which is great, right? That's what we're going to be doing with limiting reactant. So what we're going to say here is, how much ham am I going to need? Well, every reaction requires 1 piece of ham. So I'm going to use up 8 pieces of ham, right? I'm going to have 14 pieces of ham left over, which really is all you're going to be doing when you do the calculations for limiting reactant. I can make 8 sandwiches. I apparently have plenty of ham. What's really going to run out here is the bread, right? I'm going to use up those 16 pieces of bread. They're going to be gone, and I'll make 8 sandwiches. Now, here's 14 pieces of ham still sitting there thinking, hey, I'd like to make a sandwich here. But I don't have any bread. So sandwich making is over, all right? You have the limiting reactant is bread. There's no limiting reactant left over. We're going to use up 8 pieces of ham, meaning I have 14 pieces of ham left over because that was my excess reactant. This was my limiting. And my limiting is going to tell me how much product I make. Okay, so let's take a look here and just apply it to chemicals, which are not as fun, but they work. All right, so what if I have this equation, 1 mole of methane and 1 mole of water makes 3 moles of hydrogen and 1 mole of carbon monoxide. So if I had 2 moles of CH4 and 2 moles of water, how many moles of hydrogen could be produced? Now, in previous problems, we've started with grams of this or grams of that, and we've been told, oh, you've got plenty of the other, excess the other. How much hydrogen could you make? Well, here what we have to consider is, well, which one's going to run out first? Because that's the one I'm going to use to find my product. But it turns out here that they run out exactly at the same time, right? We have 1 mole of this, 1 mole, 1-to-1 ratio, 2-to-2. And so both of them run out. There really is no limiting reactant in the sense that they both run out at the same time. So it really isn't going to matter what I do here. I've got 2 moles of CH4. And for every 1 mole of CH4, I should be able to make 3 moles of hydrogen. Okay? Now, this changes a little bit when we say, well, let's say that we had 5 moles. It only changes in what you have to think about. Let's say that I have 5 moles of water. How many moles of hydrogen could be produced? Now, do I start here? Do I start with the 5 moles of water, or do I start with the 2 moles of methane? Well, we can see here, and sometimes it's not as easy to see if I don't have a 1-to-1 ratio. I could, have any coefficient here, right? But if I have a 1-to-1 ratio and I have 2 and 5, you can clearly see that CH4 is going to run out first. I'm going to use up 2 moles of water with 3 moles of water left over. And it's really going to be the same thing, right? Because this is what I'm going to use. That's my limiting reactant. And this would be my excess reactant. And you could calculate how much of the excess reactants left over by looking at, well, how much did the limiting use? Well, it's 1-to-1, right? So I'm going to use up 2, and I'll have 3 moles of water. And the calculation will be the same here. I'll be 2 moles, and it's a 1-to-3 ratio. Now, this one's pretty simple, simplistic, because I'm using really, whole numbers, small numbers. It's a 1-to-1 ratio, but nothing is really, the process is not going to be any different if I use more complicated numbers and not 1-to-1 ratios. So let's take a look at a couple of them here. All right, so given the following reaction and 2.5 moles of each, and I always write it down here, right? I figure out how many grams do I need. All right, so if I had 2.5 moles of each reactant, then what's going to happen here is that they will, again, because it's 1-to-1, they both run out at the same time. So it really would not matter. I could take 2.5 moles of Al, and I could say 1 mole of aluminum is going to make 1 mole of aluminum phosphide, and do that calculation. Well, let's do something that's a little bit trickier and say, well, what if I have 2.5 moles of aluminum? And they don't always give it to you in moles, right? Sometimes it's grams. You just got to get it to moles. How much could be produced? Now, again, this is actually fairly simple too, because what you're going to say is, well, which one's limiting? Well, clearly it's going to be aluminum, right? So if you had to write that out, you'd say, well, 2.5 moles of aluminum, 1 mole of aluminum, I'm going to use up 1 mole of phosphorus. So I am going to need 2.5 moles of phosphorus. I'm going to need that to react with that. Well, the next thing you do is you really just look and see, do I have 2.5? And the answer is yes, I have 2.5. In fact, I have more than 2.5. And so what I can say here is that, and again, even though these are pretty easy, coming back up here and saying, well, that's my limiting and this is my excess is important, because you can see what you need based on this 1-to-1 ratio here is you need 2.5 moles of phosphorus. And you're going to compare it to what you actually are being given in the reaction. You see, well, I have 6.2. I have way more than I need. Now, if this number had been, say, 1, I have 1 mole of phosphorus, you come back and go, oh, I do not have enough. I need 2.5. I only have 1. Okay, and then that would have been limiting and that would have been excess. But here we are. We have the 6.2 and the 2.5, so we know that's limiting. So I'm going to take 2.5 moles of my limiting and go to the balanced equation. Again, it's 1-to-1. and find out how much product. And I can make 2.5 moles of aluminum phosphide. And of course, I can always get that back to grams. What does 1 mole of aluminum phosphide weigh, and convert that to grams. Now, as far as the excess reactant left over, what we're going to find here is that I started this whole thing with 6.2 moles of phosphorus. I used up, because it's a 1-to-1 ratio, and I started with 2.5 moles, I used up 2.5 moles of phosphorus in the reaction. Okay, so that's why it's important, because this one's pretty simple to write down, hey, which one's limiting, which one's excess. Just keep stuff straight. So I have 3.7 moles of phosphorus left over. And again, you can always one mole of phosphorus. Okay. All right. So from the periodic table. And again, and I've mentioned this before, but anytime that you're converting from moles to grams, you're going to just use 1 mole, okay? The balanced equation isn't going to come into play here. You're just going from grams to moles, moles to grams. All right, let's end this with one other here. Let's actually do one where we start with grams. So let's take a look. I have 2,500 grams of nitrogen, 500 grams of hydrogen, and we want to know how many grams of ammonia, okay, that we should theoretically produce. And how many grams of the excess reactant are left over. All right, before you start anything, just get it to moles. Just silly to do anything without getting that first to moles. Okay, so I'm going to take that 2,500 grams of nitrogen, and we'll get it to moles. So it looks like I have 89.3 moles of nitrogen. And again, if you keep 2 or 3 sig figs, you're good. And I have 500 grams of hydrogen, 2 grams. Okay. All right, so I would go through here and just again get those to moles. All right, so I have 89.3 moles of nitrogen. I have 250 moles of hydrogen. Okay, well, which one's limiting? That's the big thing. That's why these problems are a little bit harder. So it's a 1-to-3 ratio now. So I'm just going to start with this one and go, I've got 89.3 moles of nitrogen. It's going to react in a 1-to-3 ratio. So now you're not calculating anything product-wise quite yet. What you're saying is I am going to need that much. Okay? Now come back here, draw the arrows if you need to. If I need 268 moles to react with 89.3 moles of nitrogen, do I have it? And the answer is no, I do not have it. Okay, I need 268, I only have 250. Automatically, that's limiting, that's excess. Okay, now again, if this number had been different, let's say it was 300, I'd be like, oh, I need 268, I have 300. Oh, I have way more than I need, that's excess, that's limiting. Okay, once you do that, make sure that you take your limiting, okay, what you have of your limiting. Don't use 268, you don't have it, okay? You have 250. So 250 moles of hydrogen, and that's what I'm going to use to find the product, okay? According to the balanced equation, our recipe, 3 moles of hydrogen is going to make 2 moles of NH3. So I'm going to go 250 times 2 divided by 3, and I have 167 moles of NH3. Now, it did tell me that it wants grams. Be careful. Sometimes the problem is just like, hey, how many moles? It's like, oh, wow, beautiful. Okay, so if you have to convert to grams, you guys have done that over and over again. You know that that's not going to be, and I just rounded to just 2 sig figs. Okay, so that's how much ammonia. So that's your first step. These are kind of long problems. How many grams of the excess reactant is left over? Now, the excess reactant is here. And I had 89.3 moles of it. So what I have to do is say, all right, well, This is a 3-to-1 ratio. The limiting reactant is going to tell me the product. The limiting is also going to tell me how much of the excess got used up, right? So I'm going to take that 250 moles, again, of hydrogen, and I'm going to say, all right, well, I used it up. 3 mole for every 3 moles of hydrogen, I used up a mole of nitrogen. So I used up 83.3 moles of nitrogen used. Needed, used, whatever you want to talk about it. So I started this off with 89.3 moles of nitrogen. But I used up, according to the limiting reactant, that much. Okay? So I have basically 6 moles of nitrogen left over. And I can always get that back to grams. Grams. Okay. So I have 167 grams. I could change around that. 2 or 3 sig figs is fine. So 167 grams of nitrogen. All right, so that's pretty much how you're going to do the problems. The last thing I can leave you with is the more that you write down, the clearer you are about that, the easier the problem is going to be because you're going to be able to go back and see what you've done. All right, so